Every electronic device you interact with, from your smartphone to your smart home, is a marvel of intricate engineering. But what if we told you that the building blocks of this modern world have a fascinating history, stretching back centuries? Join us today as we take a deep dive into the evolution of passive electronic components, the unsung heroes that power our connected lives. Our journey begins in the 18th century, with the very first attempts to harness electricity. Imagine a world without reliable ways to conduct or store electrical energy. That all began to change in 1729 with the concept of wire conductors, paving the way for the movement of electrical signals. Fast forward to 1812, and we see the first instances of cable insulation, a crucial step for safety and efficiency. By 1845, metal sheathing provided even greater protection. But what about the power source? In 1800, Alessandro Volta gave us the Volta's pile, the precursor to modern batteries. Early batteries were clunky and often dangerous, but they laid the groundwork. We saw the accumulator emerge in 1803, and by 1839, the very first fuel cell appeared. The lead-acid battery in 1860 was a significant leap, eventually leading to the dry cell, and much later the lithium battery in 1973, a game-changer for portable electronics. To truly manipulate electricity, we needed components to store, resist, and manage its flow. Enter the capacitor. The infamous Leyden jar, invented in 1745, was one of the earliest forms, able to store an electrical charge. Over time, materials like mica in 1874, paper in 1876, and ceramics in 1900 revolutionized capacitor design, leading to the compact components we know today. Electrolytic capacitors from 1922 were particularly important for their high capacitance in a small package. Next, the resistor, the component that controls current. While the thermistor appeared around 1850, the more common molded carbon resistor emerged in 1885, followed by carbon film and cracked carbon resistors in the early 20th century. These simple yet vital components allowed engineers to precisely control the flow of electricity in their circuits. And then there are inductors. These components store energy in a magnetic field. Early examples include iron dust magnets from 1772 and the solenoid in 1825. The development of ferrets in 1909 and later Ferrix cube in 1955 dramatically improved their efficiency and performance. The ability to convert sound into electrical signals and back again was a monumental step. The first diaphragm microphone appeared in 1860, followed by innovations like the carbon microphone in 1877, which was crucial for early telephones. The condenser microphone from 1917 and the moving coil microphone from 1922 further refined audio capture. And what about output? Earphones and electromagnetic loudspeakers both emerged in 1877, transforming how we experience sound. The moving coil loudspeaker, also from 1877, became the dominant design, and by the 1930s we had stereo sound. For recording, the journey was equally fascinating. Steel wire was used for early magnetic recording in 1808, eventually leading to steel tape in 1898 and then plastic tape in 1920. The breakthrough of ferric oxide tape in 1930 made mass production of recordings possible, paving the way for videotape in 1958 and the ubiquitous cassette tape in 1963. For any electrical system to function, we need ways to connect, disconnect, and control circuits. The simple electrical plug and socket appeared as early as 1840, and by 1878, the single-pole jack was invented, recognizable in early telephone switchboards. As electronics became more complex, so did connectivity, with rectangular multipole and circular multipole connectors appearing in the 1920s and 1940s respectively. Switches also evolved dramatically. From step switches in 1889 to the familiar toggle switches of 1910 and push-button switches by 1915, these components gave us direct control over circuits. Micro switches in the 1920s allowed for precise activation, and rotary switches from the same decade offered multiple selections. And to control circuits remotely or automatically, we had the relay. The telegraph relay in 1837 was a foundational invention, allowing electrical signals to be amplified and retransmitted over long distances. Later innovations like the PO 3000 type from 1900 and sealed relays from the 1940s made them more robust and versatile. As electronics advanced, so did the need for components that could refine and direct electrical signals. Metal rectifiers were crucial for converting alternating current to direct current. Early versions like copper oxide from 1920 and selenium from 1938 paved the way for the more efficient germanium in 1952 and silicon rectifiers in 1955 that are, pretty much everywhere today in power supplies. Equally important are insulators, which prevent unwanted current flow. Standoff insulators from 1910 and terminal boards from 1920 were essential for safely mounting and connecting components in early electronic assemblies. For higher frequency signals, especially in radar and microwave applications, waveguides became indispensable. The theory of waveguides emerged in 1893, but their practical construction for guiding electromagnetic waves didn't happen until 1936, opening up new possibilities in communication and sensing. It's easy to focus on the flashy inventions, but these passive components, wires, batteries, capacitors, resistors, inductors, switches, and more, were the silent revolutionaries. They may not generate signals or perform complex calculations, but without them, the active components like vacuum tubes and later transistors would be useless. They form the fundamental infrastructure upon which all electronic innovation is built. From the simple galvanometer of 1820 that detected electric currents, to the sophisticated precision variable capacitors of the 1920s used in radio tuning, each development, no matter how small, pushed the boundaries of what was possible. So, the next time you power on a device, take a moment to appreciate the centuries of innovation that went into creating those seemingly simple wires, resistors, and capacitors. They are the bedrock of our digital world, continually evolving, shrinking, and becoming more efficient, yet still performing the same fundamental functions that were discovered hundreds of years ago. The history of passive components is a testament to human ingenuity and the relentless pursuit of progress. It's a journey from basic observations to complex integrated systems, all built on these foundational elements. What part of this electronic journey surprised you the most? Let us know in the comments below, and don't forget to like this video and subscribe for more deep dives into the world of technology.